heating NaCl with concentrated H2SO4 and MnO2 results in oxidation of manganese. Let us write the reaction. If we are heating NaCl with MnO2 and H2SO4, then Cl2 gas will be released, and then we would also get MnCl2 and also sodium bisulfate and water. These are the things we would get. Let us balance the equation. We have 4 chlorine atoms on the product side, so therefore 4 NaCl. We have 4 sodium atoms on the reactant side, therefore 4 times sodium bisulfate. We have 4 sulfur atoms on the product side, so therefore 4 times H2SO4, and now we have 8 hydrogen atoms on the reactant side, so therefore here we have 4, therefore 2 times water. Now if you see the oxidation state of manganese here, in MnO2 the oxidation state of manganese would be +4, isn't it? Because for each oxygen we give -2, so therefore that would be -4. In MnCl2 it would be +2, isn't it? Because for each chlorine we give -1, therefore -2 here, which means +4 to +2, that is reduction, isn't it? +4 to +2 is reduction, but the question says it is oxidation of manganese, so therefore statement 1 is incorrect, which means option 2 is wrong, option 4 is also wrong. And now in the next case we are heating sodium iodide with the concentrated sulfuric acid and MnO2, that results in the reduction of Mn. This should be correct, because now if we write the reaction, instead of NaCl we have NaI, which means I2 would be released. We have MnO2 plus H2SO4, so iodine gas will be liberated and we would get sodium bisulfate once again. Unless you heat it at a high temperature, we won't get sodium sulfate. There are sources that would say that we get sodium sulfate, but getting sodium sulfate is possible only if you heat it above 200 degrees centigrade. So therefore in normal laboratory conditions we don't go to that high temperature, so therefore writing sodium bisulfate is completely okay. And we would also get MnSO4 and water. So now if we balance the equation, then we have to put 2 in front of NaI because I2 is here, which means that we have 2 sodium atoms on the reactant side, so therefore 2 sodium atoms on the product side. Now we have 3 SO4 on the product side, therefore 3 times H2SO4. Now if we check the number of hydrogen atoms, on the reactant side we have 6, on the product side also we have 6, so therefore everything is balanced right now. So here if we check the oxidation state of manganese, then +4 here, and in the case of MnSO4 it would be +2 for manganese, isn't it? Because for sulfur it is +6, for each oxygen -2, so therefore 4 times -2 -8. Therefore if we add everything together it becomes 0. So the second statement is correct. It is indeed reduction of manganese. This means statement 1 is incorrect, but statement 2 is correct. Therefore option 1 is correct.